Okay, so for this video, we are going to write the equation for a power function. So again, we've been doing the equations for lines, and then we did quadratics, we did exponentials on the last set of videos, and then this is going to be for your power function. Now, do not confuse your power function with your exponential. So the difference is, again, your exponential is y equals a, b, x is in the exponent. Your power function, your x is no longer in your exponent, it is just in your base. And so your power function would be something like y equals 3x squared. So where you have your x to a power. So that would be an example. So we're going to go run through basically the same type of steps that we ran through with the exponential. A little bit of difference, but no, not a whole lot. So again, your first step is going to substitute your x and y into your basic equation. Okay, and we're going to do that for both sets of points. So our first equation that we're going to get, okay, and I'm using the 0.59, is going to get us 9 equals a, my x is 5 to the b, okay, and then that's multiplication. Okay, my equation 2 with the 0.834, okay, is going to be 34 equals a times 8 to the b power. Okay, so all I've done is substitute into my basic equation for my x and my y. Your second one, just like our last, is we're going to solve one equation, and I usually say the first, that's the one I go with, is the first, for a. Okay, so I'm going to take equation number 1 and solve for a. Oops. So that means I need to divide both sides by 5 to the b power. Those are going to cancel. So a, I'm going to flip this around, is 9 over 5 to the b power. Now, just like our last one, we're now going to substitute, okay, a into equation 2. Okay, so equation 2, and you know, if you label those, it does make help you out, also organize your thought process, try to keep things organized and not chaos. So equation 2 was 34 equals a times 8 to the 6th. And on this one, we are going to substitute in, that's not 6, that's a b. Sorry, my bad. So if I can erase that, whoops. We'll go back there. I was talking and not thinking, I can't read my own writing. That is not a 6, but a b. So 34, 8 to the b power. Okay, and we're going to substitute in a. So 34 equals a, which is 9 over 5 to the b times 8 to the b. Okay? Now, next step, and let's make sure you do understand what we're doing here. Because both of these are to the b power, okay, what I could think of it as this, because remember, if I have a power, if I have each one of these to the power, then I would, okay, write it like that. So I could, I'm kind of a backwards thought process. And so we would have 8/5 to the b power. So I have 9 times 8 over 5 to the b power. Now, if that reduced, you would definitely want to do that, but in this case, it does not. So my next step, again, would be to divide by 9. So I have 34 over 9 equals 8 over 5 to the b power. Now, once you get it to the b power and you get down to this point, again, anytime we want to solve an equation in which the variable is in the exponent, which is what this is, okay? We have the variable in the exponent. Remember, we want to do the log. So we want to go to log. So that would be log, okay, base 8 over 5 of 34 over 9. These are some weird numbers, equals b. And you can actually run that then into your calculator because we're going to do the change of base. Okay? So that would be, I'm going to, whoops, my bad. Okay? I'm going to go ahead and take this off. So we're going to do a change of base. So that would be the log of 34 divided by 9 divided by the log of 8 divided by 5. Now, you are going to have to close those parentheses up, so don't forget that. So I'm going to go ahead and real quick and run that. So I get the log of, 34 divided by 9, close my parentheses, divided by, now you can do it all in one step if you want, just be sure you close up those parentheses. Log of 8 divided by 5, close my parentheses, and I get b to be, and we want to go to the nearest thousandths, 828, sorry. And I would go ahead and run that yourself to see if you get those numbers, see if you agree with me. So there's my b value, okay? Whew. Now I want to go find my a value, okay? So my next step, this gets a little long, okay, is we're going to substitute back into part or step number 2, okay, B, and solve for A. Okay, so I'm taking that number back into here. This is what I had, 9 over 5 to the B. B is 2.828. And again, I'm going to put that in my calculator. So I'm going to put 9 divided by 5, and then I use the caret key. Okay, 2.828. If you don't know where the caret key is, I can help you with that. And I get 0.0949, but that's going to round to 50. Okay, so you're not always going to get nice numbers on these. So my basic equation then would be, I'm going back to the top, all the way back up to the top, y equals AXB, sorry, y equals AXB. So this would be y equals A, x to the b. Wow. So don't be surprised if you end up with some decimal values. That definitely happens, especially when you're working with power functions and or exponential functions on there. So again, there was my problem. It was 59834. I'm just going through and checking my answer in the book. And the book, now the only thing different in here is this book went ahead and rounded to the nearest hundredth where I said thousandths, but that's not that big of a deal. Okay, so just a little bit of difference in the rounding. But those are your steps. So basically the same steps. This one's going to get just a slight bit more complicated, again, because you are going to have to use logarithms on that. So I'll run through another example just to show you.